Thank you very much, Delaney, and thank you to the South Dakota corn growers for bringing me here to talk about the weather. Obviously, 2020 threw us a lot of curveballs weather-wise as well, along with a lot of other things. What I'm going to do in today's presentation is discuss a little bit about what has happened and what we're expecting going forward, and we'll end with a long-range forecast for the spring and summer. One thing that I like to do is be able to show how the past helps us predict the future a little bit. So I always like to do a little bit of a rewind. As we go forward into the future, I'm going to always go back to the past a little bit as I do something what is called analog weather forecasting. Analog weather forecasting is where we take a look at what has happened in the past to help us get an idea of what we are going to see in the future going ahead. So, oops, let me see here. Not quite able to advance the slides yet. I can go ahead and give you an audio cue. Okay, thank you very much. So what we'll do going forward here is I've got a lot of slides to throw at you, so keep your finger ready over there. So what we'll do is we'll go back, we'll take a look at the past 5 years, identify the patterns that give us wetter patterns, and identify patterns that give us warmer, drier patterns, because we have experienced both here in the last 5 or 6 years. So what we had in 2013 to 2019, generally speaking, in this region, South Dakota, Minnesota, parts of South Dakota in this region, is we had a fairly good stretch of weather. 2013 to 2019, we had, generally speaking, adequate soil moisture. We had good heating degree, corn degree accumulations, things that worked out pretty good. What you're seeing on the screen right now is what the drought monitor was a year ago. As you can see, there's a lot of white. And if you see a lot of white on a drought monitor, that means your soil moisture conditions are near average. Anywhere you see a color that's yellow, orange, or brown, you're looking at drier conditions. So you can see, with a few exceptions, Texas, parts of the Southern Rockies, and the Pacific Northwest, we had a pretty good situation. We had good soil moisture. Go ahead to the next slide, please. And we started last year, as we all know, how wet 2019 was, with really deep soil moisture conditions, off the chart soil moisture conditions. So it's hard to imagine how we could go and do a 180, but we did. Go ahead to the next slide. This is where we are as of this past drought monitor. You can see the expansion of the drought conditions in the southwestern United States, the Rockies, California, and then pushing into the Dakotas, western and northwest Iowa, and parts of Minnesota and North Dakota. We just basically did a 180. Go ahead to the next slide, please. You can see the soil moisture change. In a year, you can see that soil moisture conditions did a complete flip, which is really remarkable considering how moist it was in 2019. Delaney had mentioned about how wet it was in some areas at planting, but at the end of the summer it was completely opposite. And if we go to the next slide, we can see where we had the change in soil moisture conditions. And that's a very busy map I'm showing you, but you can see the bullseye of this change in soil moisture conditions right across eastern South Dakota, southern Minnesota, Iowa. This whole region saw the biggest change in the lower 48 in a year in soil moisture conditions. So you weren't imagining things in terms of how things really changed. So go ahead to the next slide. 2019, this is where I'm going to do a little bit of a rewind. As we all know, 2019 was wet. This is a graphic showing normal precipitation above average or below average. Anywhere you see the purple and the blue or the green, it was a wet year. And you can see just about all of the nation had a great year, too good of a year in some areas for precipitation. Now, if we go to the next slide, we look at temperatures. Temperatures were at average or a little bit below average. It was cool and wet. Now, if we go to 2020 on the next slide, you can see that things reversed. Temperatures were a little bit warmer than normal. You can see that actually the United States on the whole really did not have a hot summer, except in the northern plains and parts of the northern western Corn Belt. Precipitation-wise on the next slide, you'll be able to see that the dry conditions with a bit of a bullseye there in eastern Nebraska, western Iowa, southeastern South Dakota in terms of the departure from normal for precipitation. Only the southeastern United States, thanks to a lot of tropical activity, had a wet year. So if we go forward, go ahead on the next slide. You can go ahead and go one more. There we go. I'm going to just go through a couple of slides here really quickly just to focus in on the local situation. This is a map of South Dakota, the departure for precipitation in 2020. With a few exceptions, most of the state had below average precipitation, especially southeast South Dakota. Next slide will show us what we were doing in Iowa. You can see central and western Iowa, much different than Minnesota there. You can see it was a little bit better, but still had some real dry pockets in there. So as we take a look at what has happened in the past, we have to ask the question, well, what happened? Why such the change? Well, go ahead to the next slide. After that was, okay, what we had was a major shift in sea surface temperatures in the subtropical Pacific. We went from a warmer pattern in the Pacific to a colder pattern during the spring of 2020. What we had for about 5 years, generally speaking, was a dominated pattern of what we call El Nino, when the subtropical Pacific is warmer than normal. It went colder. Go ahead to the next slide. And we went from that wet pattern to one that was colder and drier. One thing to really keep in mind is that there is a really strong influence in our climate in the lower 48 states based on what the oceans are doing. The oceans drive a lot of what we experience with our weather and our climate. This part of the country is on the easternmost edge of where El Niños and La Niñas have an impact. They don't have an impact same in every parts of the country, but for the western states, the western high plains, and the far western Corn Belt, we are really influenced strongly by what the Pacific does. When the Pacific gets cold, we get dry. When the Pacific gets warm, we get wetter. So it really behooves us to pay very close attention to what's going on somewhere that's 2,000 to 3,000 miles away. It's kind of hard to wrap your head around it, but something that far away really will impact our general patterns, especially during the growing season. Why is this important to track temperature? Because temperature is, in a lot of ways, energy, and so is water vapor in the air. When the waters are warmer, there's more water vapor. I like to use the analogy of going to the bathroom and starting a hot bath. You go in, you fill up that bathtub with hot water. What happens to the mirrors? They fog up because there's water in the air from the steam. Conversely, if you were to make a cold bath, you would have no dew. You would have nothing on your mirrors or the surfaces that got cold. You basically have less water in the air when it's colder, more water in the air when it's warmer. And so when you change those things, go ahead to the next slide. So basically, when the waters are warmer, it's wetter. When the waters are colder, it's drier. So if we take a look at, I'm going to show you some sea surface temperature maps. Again, these are really busy maps, but I want you to just pay attention to the colors. Wherever you see blue or green, those are colder than average sea surface temperatures. Oranges and yellows are where they're warmer relative to average. So go ahead to the next slide. And what I'm going to do is show you 3 areas of the Pacific and the Indian Ocean that we watch very closely. One is up in the Gulf of Alaska, 2 is the subtropical Pacific, and if you tap the space bar one more time, you'll get another one there in the Indian Ocean. Those are the 3 areas we watch very carefully. If we were to graph sea surface temperatures over time, you would notice, going back very far, we have these fluctuations, and you can see this in the graph on the next slide here, to where you see these alternating periods of warmer and colder water temperature conditions. This graph starts in 1982 and goes to current times. Anywhere you see the blue, the Pacific is cold. Anywhere you see the red, the Pacific is warm. You can take a look at this graph, and you could actually correlate when soil moisture and precipitation was good relative to normal when the Pacific was warmer, and these cold periods you can connect when they were drier. Notice the far right side of the graph, you have a very big dip in sea surface temperatures, and if you were to go left on the graph, you would see that the last time we had anything this cold was around 2011 and 2012, which, as we know, if you guys remember, I'm sure a lot of you do remember, how dry of a year that was. So go ahead to the next slide, please. This is what sea surface temperatures looked like in January 2016. You can see between South America and Australia, it's warm. El Nino, we're going to be wet. We were. Go ahead to the next slide. 2019, a year ago from today, this is what we were looking at. We were looking at a warm Pacific. This gave us that wet pattern that we had in 2018, 2019. Next slide, please. What happens when the Pacific turns colder? Well, here we are. This is a good example. This is a snapshot of sea surface temperatures as of this week, and you can see a lot of blue and the green near the equator. Again, think of the equator as not only just a great place to be, sunshine all the time, it's always warm, but when those waters near the equator are warmer, it's releasing more water vapor into the air. You get more water vapor, you get more energetic storms, you just have more rain, you have more snow in North America, especially Central and Western North America. So when you change the Pacific, you really change things. Go ahead and next slide, please. Analog forecasting. I talked a little bit about what happens during analog forecasting, where we go back and we look at previous years that are similar to this one. Well, 2011, January 2011, the sea surface temperatures in the Pacific were cold. You can see that there. Go ahead to the next slide. 2012, they stay cold. We had back-to-back years where the Pacific was cold. Go ahead to the next slide. And what ended up happening is almost all the United States, with the exception of the Pacific Northwest, had a drier than normal 2012. So if you want to go back to where the last real dry period was, it was 2012, which coincided with the La Nina that spanned over 2 years. Go ahead to the next slide. This will show you what the precipitation and temperatures were like. You can see, look at all the red. This is a map that shows what the temperatures were relative to average. So it's a warning sign, it's a signal, so to speak, that when the Pacific get cold, the trend is going to be drier. It's not going to be the same everywhere across the country, but this part of the nation, westward, is really influenced by it. Go ahead to the next slide. It's not always a perfect match, but follow these sea surface temperatures as a producer. Keep a very close eye on what they're doing. Follow those trends. I always like to say trend is your friend. Go ahead, please. Trend is your friend. When we get into the spring and summer seasons, especially as we get into March and April, get online, get on the internet, Google sea surface temperatures. There's a variety of different free sites that you can get that show you what they're doing. The problem we have right now with how things are communicated is that the media will report only when it's an official La Nina or an El Nino. However, there are trends that will show up that will tell you an El Nino or an El Nino is coming before actually one happens. So a lot of times we get word of a La Nina or an El Nino too late. How do these sea surface temperatures change? That's a common question I get. That's a great question, and if you could figure it out, you'd probably get a Nobel Peace Prize. But we do know this, is that sea surface changes happen all the time. They have happened for thousands of years. The sea core drilling out in the Pacific has shown that this type of phenomenon is not a new one. It's been going on for a long time. There's solar influence, volcanic vetting on the ocean floor, upwelling of currents. There's a lot of things that come together. The oceans are very complicated, but they do change temperature. Go ahead, please. Solar influences. I'm going to spend just a brief amount of time here on solar activity because it's really important. This is something else for you to keep really close eye on. First of all, know where you are in the solar cycle. Go ahead to the next slide. When the sun goes active, meaning lots of sunspots, the Earth is hit with a decreasing amount of cosmic rays. Conversely, when there are very little or no sunspots, the Earth has less cosmic rays. This would be a whole new different presentation. There's a lot to this, but it's very important to understand where you are in the solar cycles. Go ahead to the next slide, please. If you have low solar activity, we just got done with our solar minimum, you have a general increase in cloud cover across the oceans of 2 to 3%. Now, you might say 2 to 3% of increased cloud cover in the oceans is not very much. However, instead of trapping heat, the clouds block the heat, and so what will end up happening is you see your ocean basins cool off after solar minimums. Conversely, during solar maximums, they tend to get warmer. So go ahead to the next slide, please. So, Solar activity is important. Decrease in solar cosmic rays leads to cooler temperatures. Conversely, high impacts of cosmic rays when they're higher leads to warmer sea surface temperatures. So what happens when you have a solar minimum meet up with a La Nina? You have 2020. You have 2011, you have 2012. Go ahead to the next slide, please. So where are we on the solar progression cycle? That arrow shows right where we are right now. Notice that we hit the bottom. We're coming out of the solar cycle, and we're getting more active. We actually have gone 12 days now without any sunspots, but we've started to see some. So the forecast is, and this is a pretty reliable forecast, the solar maximums and minimums go through 11-year cycles. Next slide, please. So there appears to be a link between these 11-year solar cycles and the frequency and the intensity of La Ninas and El Ninos. I would like to tell you that every El Nino and every La Nina is exactly the same and that we can make an exact prediction based on whether or not one's going to happen or not, but they have varying intensities. So when we look at the solar cycles, and if we were to overlay the El Ninos and La Ninas, it's something very interesting shows up. Go ahead to the next slide. Now, this is a very busy graph, but there's a few things I want to show you. First of all, the last 3 solar cycles are highlighted left to right. Notice the decreasing amplitude trend. Solar activity is decreasing pretty significantly over the last 3 solar cycles. If you were to look at when the El Ninos and El Ninos, La Ninas and El Ninos happen during these solar cycles, we tend to have La Ninas at the base or the bottom of the solar cycle. 2 years later, we tend to have an El Nino, and then we go through a cycle. The good news is that when we get into these drought periods and these wet periods, they tend to cycle through, and you tend to get out of them. A lot of this is strongly connected to these sea surface temperatures. So you can make a prediction, and we were able to make a prediction in 2019 that 2020 or 2021 was going to bring on a La Nina. I was hoping that we were going to be able to get through the summer of 2020 with better precipitation in many areas of the Corn Belt. But we all know what happened. We went drier. So La Nina got started a little bit earlier. The question that we're looking at is, will this La Nina be strong enough to last 2 years and go through this growing season and perhaps into the growing season of 2022? Since we just went through the most intense solar minimum in over 100 years, there is a pretty strong indication that this La Nina could have some legs, which isn't necessarily good news when it comes to precipitation. Next slide, please. So if we continue to see the solar trends continuing to get less active, the solar activity to be less and less, basically what that means is the El Ninos, they'll still happen. They're still going to be there. There's still going to be warm periods, but they tend to be less intense. And the La Ninas tend to be more intense. So the wet periods going forward over the next 10 to 20 years may be less frequent than the dry periods, which is a reversal of sort of where we've been here over the last 10 to 20 years in some parts of the Corn Belt and Midwest. Go ahead for the next slide. So this is where we are right now with sea surface temperatures. Next slide, please. And another busy graph here, but what I want to show you here is that this is a bunch of computer models predicting what sea surface temperatures are going to do. Anything below the line in the middle is a negative sea surface temperature anomaly. And what all of those lines are indicating is that at least through May and June, La Nina is going to continue. It's not going to revert back to an El Nino for the rest of the winter and for the beginning of the spring. Why is that important? That is a dry signal. That is a dry signal for the southern plains, Texas, New Mexico, Oklahoma, Kansas, Colorado. It is a dry signal for most of the northern high plains, western high plains, Rockies, and the far western Corn Belt. Now, as you get a little bit further east into the Ohio Valley, the eastern Corn Belt, the influences tend to drop off. Next slide, please. So the remainder of the outlook for winter 2021, as we all know, until very recently, as of last couple of days, we really have not had many winter storms, have we? It's been a pretty mild winter until recently. La Nina, a big part of that. One thing that La Nina does is that it causes strong jet stream winds because of that temperature gradient out there in the Pacific. The stronger the jet stream winds are in the winter, the more that Arctic air is held back into Canada, the higher latitudes. Arctic air has a harder time making penetration south in La Ninas. So that's one reason we've had a mild winter. Now, what is going to happen for the rest of this month and into the beginning of February is I do think we're going to get into winter. We're going to have more situations like we just went through here recently, and it will probably go into a good portion of February. The trend is for some winter to finally come into the northern parts of the United States. However, it's off to a very late start compared to what we're normally used to. Next slide, please. So if this La Nina continues, which it looks like it's going to, the trend of drier conditions and warmer than normal conditions will likely persist into the beginning of the growing season, and perhaps longer. If I were to use historical trends, and if we were to use the years of 2012 and 2011, 2012 is what we call analogs, where the sea surface temperatures were similar to where they are now, then we would make a forecast, not even using computer models, that would say we should probably have another dry growing season for a lot of, at least the western areas of the Corn Belt. Next slide, please. So let's take a quick snapshot of what we're going to see over the next month to the next month and a half. And then I'm going to give you a look at what's going to happen for the summer season coming on up. So first of all, for the next 30 days, anywhere you see blue, below average temperatures, white average temperatures, yellow or reds is where it's going to be warmer. Next slide. This takes us all the way through the end of February. So you can see a lot of the United States is going to turn colder. There's nothing persistently or brutally cold. It's just that winter off to a late start is going to finally get going here for the next 30 to 60 days as it looks right now. Next slide. So this is a little bit of a rehash of what I just talked about, but it does look like La Nina is going to persist. What will happen in the summer season is that these sea surface temperatures anomalies get masked a little bit by the summer season. The sun's high on the equator, the water temperatures in the oceans warm up just from the summer season, and sometimes it's a little hard to see whether or not that La Nina or El Nino is going to continue into the next season. Next slide. So this is where we are now with those sea surface temperatures, very robust. The whole Pacific Basin, compared to a year ago, is getting colder, which is not necessarily good news when you're looking for adequate precipitation for the U.S. Next slide. Going back to the analogs. Now, 2011 and 2012 were colder than they are now. So I think that's one piece of good news is that the drought of 2012, which had these cold sea surface temperatures, if we are to have another dry year into 21, into 22, it may not be as intense as what we saw in 2011 and 2012. But that's something that we're going to need to keep an eye on. Go ahead to the next slide. So let's take a step through our long-range outlook through July. And what I'm going to show you are a series of temperature charts and precipitation charts. Now, these are not drawn by me. These are computer models. So you got to take it with a grain of salt. Any computer model with weather, you got to really take it with a grain of salt. And what you really want to focus on is not necessarily exactly on the map where you are and what the map is telling you. Trend is your friend. What you want to look for are their trends. Are their trends warmer and drier or wetter than colder in your area? So we're going to go through temperature, then precipitation for each of these months going forward. So go ahead for the first slide, please. These are our April temperatures for North America. One thing I need to tell you about the European model is it is always too warm. It forecasts temperatures warmer than they end up being, but the yellow and the orange is above average temperatures. White would be average. There's no blue there. So going into the beginning of spring, we leave March and into April with a warm signal. When I talked about those strong La Nina jet stream winds going across the nation, think of those jet stream winds picking up milder Pacific air and pushing it into the United States. And if we're cut off from that really cold Canadian air, you're just not going to have at least a spring persistently cold. Not that you're not going to have cold episodes, you will. But the trend is going to be warmer and drier. So if we were looking now on the next slide for precipitation in April, In April for precipitation, notice the brown, that's below average, green above average, white is average. You can see that the southern tier of the United States, California, Nebraska, parts of Iowa, Kansas, you're going to see below average precipitation. Does this model pick up on some of what's going out in the Pacific? Absolutely. The model is sensing that this is a La Nina and it should be drier than normal conditions. Next slide. May. May continues the trend of warmer conditions across a lot of parts of the United States. So the mild winter is probably going to segue itself into a mild spring season. And so that's a situation that bears very close watching, because we all know how important spring moisture is. If we go through the winter with below average snowfall, which is sort of where we're at right now, and we start the spring season dry, that is obviously not a good situation to be in. Go ahead for the next slide. For May precipitation, we are in a situation to where we're below average with precipitation for a lot of the nation and above average precipitation along the northern tier. But May, for a lot of the lower 48 states, is the wettest month of the year. It depends on where you are, but for the central and western United States, May is a money month to where you really count on that spring moisture coming on in. So the trend for April and May is warmer than normal. The trend for April and May for precipitation-wise is near to below normal. Go ahead for next map, please, for June. June, warm. There is no cold signal anywhere in the United States next summer, this upcoming summer. So June, the heat is in the Rockies relative to average, with most of the rest of the United States being warmer than average. You can only see a little dot there in the Pacific Northwest and northern Washington there that's cooler than normal. One thing you do see in La Ninas is you do see more stormy weather in the Pacific Northwest and Western Canada. The model, again, is picking up the La Nina continuing. Now let's go ahead to take a look at June precipitation. Again, this is not a very good forecast when it comes to getting that moisture early in the season. Below average precipitation for most of the United States during the month of June. As we go into the month of June and then go into July, it'll be real critical, obviously, to see what we're going to do with precipitation. But right now, it is showing very few parts of the United States going to have anything that resembles anything wet at the beginning of the summer. Next slide. So as we go into July, we see that the trends don't really change very much. The trend in July is going to be for warmer than normal temperatures, with the exception of the southeastern United States. Now, we are at the real cusp here of our forecast abilities. Of course, you may joke, and you rightly can joke, that we have a hard time getting tomorrow's weather. So when we're going out to 120 days, 150 days from now, 180 days, it gets a little bit tenuous with the long-range forecast. But I can't strongly emphasize enough how important these trends are, because what rain falls, what snow falls in a lot of the western and central, the western part of the central United States is derived from the Pacific. Yes, we get that Gulf of Mexico moisture coming up from the south in the spring and summer that affects the central and eastern Corn Belt, the Ohio Valley, the Great Lakes, those areas. We're right on that edge to where we're more dominated by what happens in the Pacific. So if we see these sea surface temperatures continuing to be colder than average into spring, that is a dry signal. Now let's go ahead and take a look, if we were to look at the precipitation for July. Again, this trend continues. We see some moisture in the southeast United States, but the northern tier of the U.S. and right where we are is still below average precipitation. If we were to extrapolate July's forecast into August, the reason I'm not showing you an August forecast yet is that's just a little bit too far out. But soil moisture is so important in terms of generating our summer rains, our summer thunderstorms that we really count on to bring us those heavier rains that help us get through the growing season. So one thing that we had in 2020 that we're not going to have in 2021 is really good soil moisture. We had all of that excessive rainfall in 2019 that was stored in the ground for some areas in 2020. but our soil moisture profile is not nearly as good. So if the ground is drier, it's a little bit harder to make it rain. This is why droughts are so, well, they're evil, because they feed off of each other. When you have a dry ground, you have less water evaporating from the ground back into the air to be used to help form clouds, help form precipitation. So that's why a drought will feed on itself a little bit. That's why when we take a look at what we're looking at here going into 2021's growing season, is that we have a robust La Nina, the strongest since 2011 and 2012. We just got done with a solar minimum, which increases the chance for that La Nina to be more robust. So what we're setting the stage, what I'm setting the table here for is that the odds of us shifting gears and going into a really wet summer is just not likely on the big picture. Can things change in the Pacific? Can water temperatures change? Yes, but we're not going to really know until later this spring or into early summer what's going to be able to happen with that. Now let's go ahead and take a look at the next map here. If we were to make this a composite map, let's put together May, June, and July. Let's put all those maps I showed you together. Notice the darkest brown colors, the below average precipitation, is centered in our neck of the woods, with very few areas even close to us showing green, which would be an above normal rainfall pattern. So what we're seeing here going into the summer of 2021 is regionally there's going to be some concerns. California is going to continue with its dryness. The best thing for California to get wet is an El Nino. The worst way for California to be dry is to have a La Nina. So if you're going to go with a La Nina, regionally, these are the areas we got to watch. California, the Sierra snowpack is off to an awful start, so you'll start hearing in the news this summer about the California drought. That's like shooting fish in a barrel. If you're going to get a La Nina, you're going to get a California drought. Simple. Now, as you go into the southern plains, I am concerned about the southern Rockies into the southern plains. I'm concerned about Texas. I'm concerned about Oklahoma. I'm concerned about wheat country in Colorado and Kansas. They've had a couple of winter storms this year, but that is one area. Does anybody remember hay prices in 2012? Situation that we'll be watching very closely in Texas and into the southern plains, because it's a dry signal. La Nina is a dry signal there as well. I think most of the central and northern Rockies is probably looking at a drier than normal condition as well. One thing that happens in La Nina is we see less moisture come up out of Mexico. You can see on this map, you see some green there in Mexico. That's the higher terrain in Mexico. That's what we call the North American monsoon season. Well, it looks like it's going to start, but it's not going to push very far north. The wildfires in the Rocky Mountains this summer and the wildfires in the western United States were largely driven because the summer monsoon rains did not come at their normal levels, La Nina again. So as we take a look at the United States, most of the central and western parts of the United States, most of the Corn Belt, the signals right now, the trend right now indicates dry. So where we're standing here in the middle of January is a long-range forecast that is drier than normal and a little bit warmer than normal. So this will be something that you're going to want to watch. What I would do at home is track La Nina, track those sea surface temperatures, and see if we see any robust change come, let's say, late March, May, or June, to where they start to warm up and we start to see that go away. If we see it sort of sticking around, and as we get into the fall season of 2021, if La Nina is still here, we can surmise that we're going to go into 2022. If I were to go back and talk about these solar cycles, you do get an El Nino, usually the second or third year after your solar minimum. So if I were to really stick my neck out on a really big long-range forecast, is that this current dry period is probably going to be 2 years, 2020, 2021. If we go into 2022, then you're talking about a 3-year dry period, which would rival what we saw back sometimes in the early 2000s and right around the time frame of 2011 and 2012. Interestingly enough, if you look at some of the dry periods, the last two big ones, 2011, 2012, the early 2000s, 1999, 2001, 2002, those were spaced 10 and 11 years apart. So there's really no mystery there that those team up very well with the 11-year solar cycle. So it's something that is hotly debated about these solar cycles. However, the connections, the patterns that we see with them and the sea surface temperatures in the Pacific are quite interesting and deserve more study. But these long-term patterns are a lot of times more reliable looking at historical trends as opposed to just the computer modeling. Despite the fact that we have incredibly fast computers, incredibly smart people, and incredibly smart people who put together these equations to help build our weather models, one thing they can't do is they cannot integrate these sea surface changes very well into the long-range computer modeling. So that's why you got to go back and look at these historical trends to get an idea of what's coming in the future. Most of the long-range forecasts that go south, that go bad, are only derived from computer models. So a lot of times, you got to take a step back and use a combination of computer models and what we call analog forecasting. So that completes my presentation for today. So I'm sure we'll be able to talk some more with Delaney, and as well as taking any questions that you folks may have.
All right. Well, thank you so much, Don. That was great. We do have some questions that came in while you were speaking today. And again, folks, if you want to send in your questions, that chat number, that chat box is there available for you, or you can always text in that number. That's also written in the chat function for you. But Don, one question here that came in I think was a great one. You focused a lot on North American weather, but what's the outlook for South America?
That's a good question. These patterns also impact the Southern Hemisphere as well. In fact, the whole name El Nino and La Nina comes from Chile. Because they would notice that the sea surface temperatures would change right around Christmas time, and it would change the way the anchovy fishing would be. And so they recognized in South America a long time ago that these changes would impact it as well. Now, La Nina tends to impact South America a little less. El Nino tends to be a little bit more of a bigger impact. So for South America, for the rest of their growing season, I don't see anything that looks terribly bad in terms of a prolonged drought or prolonged wet period. It's a little bit more reliable in a La Nina for the precipitation down there to be closer to average. So I think they'll end up their growing season with no big surprises.
And do you anticipate them having any sort of problems? We're about to head into their harvest season. Is it going to be smooth sailing for them?
Not completely. I do think, especially in northern Argentina and some of the growing areas of southern Brazil, there's going to probably be a couple of late season storms that could slow down harvest a little bit. That'll be something to keep an eye on. Fantastic.
We have another question here. With all these trends that you've been talking about, giving us wildfires and drought, how much of this is related to global warming?
Well, there's a question for you, right? We could talk about this for hours. Well, first of all, the connection between climate change and what we're experiencing right now, my opinion is we can make stronger connections to what's happening in the oceans as opposed to climate change. And the reason I say that is that these cycles are pretty reliable. If we were to see these cycles getting interrupted, and let's say the Pacific just stayed warmer and didn't go through these changes anymore, then the climate change argument would probably hold more water. The problem is that it's a real muddy mess to sort through what is and what isn't responsible due to climate change. I think you can get yourself really tied up and get yourself into some problems, because overall these long-term trends, these cycles that we go through, are a lot more reliable. So the oceans, in my opinion, and this is my opinion, and it's debated, and I encourage robust debate, is that the oceans drive our climate more than greenhouse gases.
All right, and you talked a lot about the oceans, which I have another question on here just in one moment. Folks, again, that number, if you have questions at any point, not just for Dawn, but for any of the speakers coming up, that number again is 605-951-0276, or you can throw any questions you might have in our chat feature in Zoom. Dawn, since you mentioned the oceans, you talked a lot about temperatures of the ocean, sea surface temperatures, and the La Nina pattern that we could be experiencing again this year. What's your outlook for South Dakota, specifically for planting? Should farmers be considering adjusting planting dates? Should they be taking any available good day they have to get the crop planted this year? Should they be holding off for maybe a little bit later in the season to adjust for any drier weather? What's your outlook there?
Well, yeah, that's a great question. The one tricky thing about La Nina is a lot of variability. You can swing the pendulum back and forth pretty quick and go from, mild like we've just been to this winter storm that we just experienced. One thing that makes me nervous in the spring La Nina is that you can have a really warm start to spring and have that one cold front that comes in and really messes things up. So my recommendation is to maybe, since we're looking at what is likely going to be a warmer summer, maybe an extended growing season, that starting planting a little later might be the better way to go.
All right. Well, Don, I think that might be all our questions for today. Thank you so much for joining.
Thanks for having me.